Assalamu alaikum students, welcome to channel again. Let's get start our worksheet. The remaining part of the worksheet, that's the second part of differentiation. As you can see, the question number 6, yes, here we stopped our working. A point is moving along the curve. Yes, we have a equation of the curve in such a way that the x-coordinate is increasing at a constant rate. Yes, I repeat my words, the rate. Rate the word whenever it comes. Yes, so the first thing that comes to our mind, yes, we talk about the time. The rate of change is given x. It is dx over dt is given, which is 0.005 units per second. It's given, right? Now, the question is, so we have dx upon dt given, and they ask you to find the rate of change of y, means they are looking for dy upon dt. But again, at the same thing, if you look at this equation, there is no connection about time in this equation at all. That's why we decided to use chain rule. What the chain rule is, let's cite. Chain rule says dy over dt is equals to dy over dx multiplied by dx over dt. If you look at this chain rule, yes, dx upon dt is given. Yes. dy upon dt, yes, we are looking for this. And dy upon dx, yes, means I will differentiate this equation and I'll get dy upon dx. Okay, let's start differentiating this equation. But remember, for before the differentiation, you must shift the whole denominator into the numerator. That's why the power becomes -1. Now we differentiate this equation, and what happens? First thing first, power will multiply the coefficient, and then there will be no change in the bracket. I subtract 1 from the power. In the second bracket, we differentiate the whatever inside we have in the bracket. So we differentiate x squared. That's why it's going to be 2 times 2x minus 1. The last thing is the number 2. It's a constant with no x. Therefore, the derivative becomes 0. So dy over dx is going to be negative 8x squared minus 2 power minus 2. And this is 2x. Now, dy over dx. What happens? This 2x will multiply this 8, gives you negative 16x, and this bracket comes down in the numerator, and the sign of the power will be changed and becomes positive. Now we substitute the value of x, which is given here. The value of x is 2. So we substitute in dy upon dx. So negative 16 times 2 divided by 2 square minus 2 power 2. So dy over dx is going to be negative 32. It's going to be 4 minus 2 square. Negative 32 and 4, it's going to be 4. So dy over dx is going to be negative 8. Now we need to use the chain rule. Yes, the chain rule. That's why I substitute the values here one by one. So dy over dt is going to be dy upon dx is -8 and dx upon dt is 0.005. 0.005. So if I multiply the two numbers, you can give your answers in decimals or you can give your answer in fractions, up to you how to deal with this. That's going to be dy over dt is negative 0.04 units per second. This is the rate of change of y with respect to the time. This is what they ask you to calculate. Okay, let's take on the next question. Yes. Yes. Can you see this? Constant rate x coordinate increasing at a constant rate means yes, the chain rule. Very good. So dx over dt is going to be 0.02. It's given. Dy over dt, the rate of change of y, they ask you to calculate. And in this case, I repeat the words, as you can see in this equation, no time, no value t, no variable t. That's why we use the chain rule. And what is the chain rule? It says dy over dt is equals to dy over dx multiplied by dx over dt. Since dx upon dt given, dy upon dt, they ask you to find out, and dy upon dx, yes, we differentiate the given equation and then substituting the value of x, which is 1 here. But before differentiation, as you notice, square root may be replaced by half. But I'm writing here minus half because the x was in denominator and we must bring in the numerator. That's why power sign will be changed. Now we differentiate the equation and the rules are same. 3 multiplied by power and subtract 1 from the power. Then 5 multiplied by power, which is minus 1 upon 2, and subtract 1 from the power. It's 3 upon 2x power minus half plus 5 over 2x power minus 3 upon 2. Now, we substitute. Now we bring the power positive and shifting in the denominator. It's 2x power half plus 5 over 2x power 3 upon 2. Now we substitute the value of x as 1, dy over dx. It's going to be 3 upon 2, 1 power half, 5 upon 2, 1 power 3 upon 2. So dy over dx is going to be 3 upon 2 plus 5 upon 2. So dy over dx is going to be 4. But yes, we are looking for the rate of change of y. That is why we use the chain rule. Substitute the values in the chain rule. So we are looking for rate of change of y. We dy upon dx we found 4, and the dx upon dt is 0.02. So we substitute here. We substitute here, which is 0.02. So dy over dt is going to be 0.08 units per second. What they ask you to find the rate of change of y. The important things is before differentiation, what you have to do, don't forget those steps. And what is the chain rule? How do we use the chain rule? Another question, again the rate of change. Yes, how I can identify this? Yes, look at this. The constant rate of value units per second. This is x. And we are looking for the rate of increase of y. Means yes, we have to use the chain rule. But before this, what we have, just write down, we have rate of change of x, which is 0.06. Then we are looking for dy upon dt, and the chain rule will be dy over dt is equals to dy over dx multiplied by dx upon dt. Schedule. So first thing first, get the dy upon dx. For this, we differentiate the equation. It's going to be y is equals to x plus 2x plus 3 power half. Okay, let's differentiate the equation. So dy over dx is going to be, this is 1 x power 1 minus 1. In the second part, let's bring this power down, that is half. Bracket will remain same and subtract 1 from the power. Then we differentiate the terms inside the bracket. 2 times 1, it is 1 minus 1. And the second part of the bracket is 3. Therefore, the derivative will be 0. Now, dy over dx. This is x power 0. It's 1 over 2. 2x plus 3 power minus half. And this is 2x power 0. The 2 cancels out. So dy upon dx is equal to 1 plus 1 over 2x plus 3 power half. Or you can write it as dy upon dx 1 plus 1 over square root 2x plus 3. But you must substitute the value of x, that is 3. So dy upon dx 1 plus 1 over square root 2 times 3 plus 3. 1 plus 1 over 3. We got the value of dy upon dx. Now we use the chain rule. apply the chain rule, get the results. We have dy upon dt. Yes, we are looking for dy upon dt. The dy upon dt is 1, and the rate of change of x is 0.06. Yes, 0.06. Therefore, the rate of change of y is same as the rate of change of x. This is our final answer. Okay, let's take on the next part. Question number 9. Find the coordinates of the stationary point on the graph. Stationary point. Yes, remember the stationary point means we have to differentiate. Yes, we have to differentiate. So let's differentiate the equation first. So it's going to be 3x to the power 3 minus 1. And this is 12 times 1 x power 1 minus 1. And the 5 becomes 0. So dy over dx is equals to 3x squared minus 12x power 0. Since I'm looking for the stationary point, therefore dy upon dx must be 0, and this is 3x squared minus 12. I need values of x. Let's move 12 to the left. It becomes positive. X squared is equal to 4, and x is going to be plus 2 and minus 2. But since we are looking for the stationary coordinates of the stationary point, means we must know the values of y. That's why we substitute each value of x in the original equation, one by one. At x2, we substitute in the original equation 2 cube, 12 times 2 plus 5. This is 8, this is 24, and this is 5. Y is equal to negative 11, means the coordinates will be 2 comma minus 11. Now we take the next point, which is x minus 2. Substituting in the original equation. So the stationary point, second coordinate of the stationary point is negative 2 and 21. Since they also are interested in the nature of these points, which one is maximum, which one is minimum, that's why we must know the second derivative. Means we differentiate the equation again. My first derivative is dy over dx is equals to 3x squared minus 5. But if I differentiate this again, okay, so it's going to be d square y and dx square. So things are going to be 6x. So we substitute each point one by one and check the nature of each point. So if x is 2, So it's going to be 6 times 2, which is 12. It's a positive number. Therefore, 2 minus 11 is a minimum point in this curve. Now we substitute the second value of x, which is minus 2, in the second derivative. So we substitute, this is 6 times minus 2. We substitute in the second derivative, there's going to be negative 12, which is a negative number. Means the coordinates of minus 2 and 21 is a maximum point in this curve. This is the way we find the nature of the curve or nature of the stationary point by using the second derivative. Okay, let's see what we have in the next question. Okay, it's integration. So inshallah, in the next video, we will start the integration. Till then, take care. Allah Hafiz.